Hello, welcome back to the channel. So let's move on to a new unit, a new concept, which is about numerical integrations. So in this video and in the upcoming video as well, we will learn some important concepts that will help us to calculate the numerical approximation of integrals. So in this video, this question is about a very simple concept on calculating the relative, absolute and the percentage errors of approximations, but this concept will be heavily used in order to calculate the numerical approximation of integrations. So we'll touch upon this topic and revise this topic such that we can do good on the numerical integration questions that we will discuss in the next videos. So in this video, you are given that suppose we approximate an object to have the volume 1.5 meter cube, which means this is the approximated volume or the calculated volume, and we also know that the exact volume is this expression over here. The exact volume of the object is 1.387 meter cube, and now you have to give the relative error, the absolute error and the percentage error of this approximation over here. And we know the basic formulas. We know that the absolute error is basically taking the modulus or the absolute value of actual volume or the original volume minus the calculated volume or the approximated volume. So this is the absolute error, and then if you want to calculate the relative error, we can basically, if you want to calculate the relative error, you can basically divide the absolute error by the actual value to calculate the relative error. The actual value in this question will be the actual volume of the object. And now if you want to calculate the percentage error is simply calculating the relative error times 100% in this case, right? So these are the concepts that you already would know about error approximations and calculating these different type of errors, but this video is only about revising those concepts such that we can easily use those concepts in the next videos. So in this question, if we have to calculate the absolute error, it would simply be the absolute value of actual minus calculated, so which would simply be 1.387 minus 1.5 in this case, right? And we'll take the absolute value because it's the absolute error in this case, right? So whatever answer you'll get by solving this expression, it will be your absolute error in this case, right? And again, for the relative error, you'll basically have this expression in the numerator, and then you'll divide it with the actual volume, which is 1.387 in this case, right? And then if you want to calculate the percentage error, you'll basically multiply this relative error that you got with 100% in this case. And you know that since it's a percentage error, it's always in the form of a percentage, right? And this relative error is basically this expression over here, right? So that's it for this video. Again, in this video, the main takeaway is to refresh your memories on these type of errors such that we can utilize the information we know about these errors in order to calculate the numerical approximation of integrals in the next videos, right? So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Take care.